In this fourth and final item, we have a thin wall pressure vessel. At least we hope we do. We got a pressure vessel at any rate. 10-inch inner diameter, quarter-inch wall thickness. Right, so if we translate that into radii, we got 5-inch inner radii and outer radii of 5 1/4. So let's just check right off the bat whether or not we have a thin wall pressure vessel or not. So our radius thickness will be 5 over 0.25. That'll be equal to 20. That's greater than 10. So we do have pressure vessel confirmed. And that means that our equations for hoop stresses and for longitudinal stresses applies. Right? Hoop is that expanding one. Longitudinal would be in the other direction. And so down here, there's your sigma h. That's going to equal PR over T. And then we'll have in tension half of that for our longitudinal, PR over 2T. And then on top of that, then we have our axial compressive stress. That's a different P, it's a capital P, and that is axial is going to be P over A. And the condition under which we're doing the analysis is that the net normal stress in the cross-section is 0. So these two then have to turn out to be 0. So we can find our axial force by equating those two. And we've got that P over A must equal little p r over 2t, so therefore P equals little p r over 2t times A. And now we just go at it. We'll have then 300 psi times our radius, inner radius down, 5 inches over 2 times our quarter-inch thickness there, times our net area, the cross-sectional area of the pipe or the vessel, so that would be pi times r squared, outer radius minus pi r squared inner radius. Right? This first number will turn out to be 3,000 psi, and the second number will turn out to be 0.05 square inches, so that you'll have an answer that is 24.15 kips.